that and take a look at some of the things we discussed. Obviously, this is a very quick review. So this is the review book version, not the textbook version, with just a few things to keep in mind. So we said that there are a whole bunch of key concepts, and I've alluded many times to Say's law, told you that the circular flow diagram with its two flows, the flow of the economy and the financial flows. And by the way, about an hour ago, I was watching Bloomberg television, and one of the people they were interviewing was talking about the two flows in the economy, the economic flows and the financial flows. And I said, oh, that's perfect. That's exactly what we do. We're talking about growth, so we're talking about pushing out the production possibilities curve. And I just mentioned the oil market, which of course is all about supply and demand. We pointed out that things are never a zero-sum game, that there are always going to be winners and losers, and nobody or no entity, a business, a government, a household is always just a winner or just a loser. I pointed out how lower interest rates could be great if you have a mortgage, terrible if the same person with the mortgage wants to put his or her money into a bank account. Well, the interest you're going to get isn't going to be there. We always look at consequences of what we do, which is very important. But what's really important to us is that we need very comprehensive measures of what's happening in the economy. And of course, the one singular, most comprehensive measure of economic activity, which talks about all of the production and all of the income derived from that production, of course, is the GDP. If you're a macroeconomist, it's the single most important statistic for you, and mastery of GDP is obviously the most important thing you can do. But really the story, even though you're a macroeconomist looking at a comprehensive figure, is to disaggregate the numbers. What's happening beneath the surface? It's great to say that this was the outcome, but unless you know what happened beneath the surface, the story's not terribly interesting. It's sort of like getting the score of a sporting event. You get the score and you say, oh, that's interesting. The Knicks won last night. But why did they win? Did they win? Were they winning end to end? Did they win in the last minute? Did Julius Randle hit a shot at the buzzer? I mean, how did they win? Did they play good defense? These are the kinds of things you really want to know. Well, it's our responsibility to go beneath the surface and disaggregate. Now, I've told you the second half of this course is all about disaggregating the GDP, so we will do that in great measure. So I think that's pretty clear. Certain things that we want to pay attention to, and that is, obviously the circular flow diagram is critically important. We talked about that. We talked about the importance of there being goals, and I've worked in government of different sorts. I worked effectively for 3 different presidents of the United States. That's on the fiscal side. And of course, for 17 years, I worked at the Fed. And there's no doubt that whether you're working on the fiscal side or the monetary side, you want there to be stability. You want there to be changes. You don't want everything to be flat because nothing really occurs then. You want there to be ups and downs, but you want them to be mild. That's what stability is about, mild changes. And you want there to be fairness. It's disturbing to any of us who look at the economy to see what the economic recovery in the US and elsewhere has been from the pandemic, to realize that some people have prospered enormously. Let's pick something at random. People who own Bitcoins are just as happy as they could ever be. But then there's so many people who have really suffered as a result of the pandemic and the closure of businesses, or the partial opening of businesses, and the losses of jobs or hours of work. They're suffering. And that's why Congress continues to consider stimulus packages, even though the economy is really working its way totally back to its feet. Of the 13 different categories of stores that are measured in the retail sales number that came out today, 9 of the 13 categories have sales now that exceed where they were before the pandemic hit. So they have fully recovered. So all of that said, that doesn't mean necessarily that if you are a small business owner in one of the boroughs of New York City that you're doing well. Just walk down any street and you see the empty storefronts. So we know that it's been different. That's not fair and that's not equal. That's not what we're looking for. We're looking for fairness. But most of all, we're looking for growth. Because if we don't get growth, none of the other things happen. You don't get stability, political stability, social stability, cultural stability, and economic stability if you don't get growth, because you've got more people and each person wants more of the pie. Nobody goes to sleep at night and says, when I wake up in the morning, may I have less than I have today? I don't think there are terribly many people who believe that. So they want more. So if you have more people wanting more things, you can have growth. So we pay a lot of attention to it. The nature of economic growth, it's really an expansion of productive capacity. And it comes about by having more and better productive resources like capital and labor, while at the same time advancing your technology and advancing your management skills. We got to get better at everything. It's as clear as that. You get better at it, which means you have more of it, and you have better quality of it, and you use it better. Because what good would it be to say that I'm a chef and you put more food in front of me to cook, and you say, your obligation is to cook all of this food, but you don't give me good technology. And the fact of the matter is, I'm cooking the same stuff I was cooking 10 years ago. I haven't added one more dish. I'm not going to be much of a chef. So we have to use the things we have better. It has to be of higher quality and higher quantity. And in a world that is increasingly competitive, where you, my beautiful students, many of whom have come to this class from other parts of the world, you know that you're competing against people from other parts of the world. If you think you're only competing against people in Manhattan or Queens or New York City, you aren't. Jobs get posted on LinkedIn or Indeed or at a college placement office, and people apply for those jobs from all over the world. And you may have been one of them. You may already be one of them. And since so many jobs are digital, you don't have to be there. So it's entirely possible a company may hire somebody to do a job. The home base of the company is in Manhattan, and the person they just hired lives in Dallas or in Delmonico. It doesn't really matter. And it's doing the job. And maybe once a month jumps on an airplane and flies to New York for a meeting. But now with Zoom, maybe you don't even do that meeting. So we now know it becomes incumbent upon our college students. It becomes incumbent upon college professors. Excuse me 1 second, I need to sneeze. Excuse me. I'm sorry about that. Anyway, so we want there to be economic growth, and we want there to be more economic growth per capita. We want there to be a bigger economic pie, but with bigger slices of that pie going to each person. That's really what we're shooting at. It's in this context that I've taught you and have asked you to try calculating growth rates. If you have not done this, if you have not looked at these formulas, if you have not gone in Excel, and if you don't have Excel, that's fine, it just makes the job harder for you. You need to learn how to calculate growth rates, and you need to calculate growth rates at annual rates. If we're going month to month, what was the growth rate of a particular series between January and February? You divide the February number by the January number, raise it to the 12th power, subtract 1, multiply by 100. If you're looking at quarterly data, how much did we grow in the second quarter? You put the second quarter number divided by the first quarter number, raise it to the 4th power because it's a quarterly statistic, subtract 1 and multiply by 100. Ladies and gentlemen, you need to know how to do that. And if you don't, you're going to get something wrong on your first exam, that's for sure. But secondly, what I'm telling you to do is go to the GDP numbers by going to BEA, as in Bureau of Economic Analysis.gov, BEA.gov. Look at the GDP numbers, calculate them yourself, and then go down to the chart in the BEA report, which actually gives you the growth rates, and see if your number is the same as what they got. So take the raw data, calculate the growth rates, and then go to the growth rate chart and go, yep, I got it right, 3.4% annualized. Then you'll know you got it. This will do a lot of things for you. This will familiarize you with the GDP numbers, which is really good. You'll see that the things that you've been taught in this class and in your previous class were correct. That there is personal consumption expenditures and gross private domestic investment and direct government spending and net exports. You'll see all the numbers, as you'll see in a moment, but it'll give you a chance to calculate this. This is your responsibility.
Professor?
Yeah.
Can you tell the website name? You said GDP.
I'm sorry, what are you asking?
The website, what just said?
Oh, sure. BEA, as in Bureau of Economic Analysis, BEA.gov, because it's a government website. So you go to BEA.gov and you will get the GDP numbers. It's a very easy website to use, very easy. Okay, so calculate some growth rates. In the end, as I pointed out in our very first class, in the end, your skill set is going to matter as much or more than what you know. You know, nobody's going to really care if you know whether or not something is counted as investment or consumption in the GDP accounts. They are going to want to know, what was the growth rate? My very first job was at CBS, and the very first thing that I did, my first day on my job at CBS, someone asked me to calculate a growth rate. It's as simple as that. It happened to be audience size, but it's what I calculated. Okay. So one of the other things that we pointed out is that growth rates are not the same all over the world, that poorer countries, meaning countries that have smaller GDPs per capita, when they start to catch up, they catch up pretty fast. They never really get to the size of the big economies, but they're catching up because their economy is smaller, and a certain amount of growth in a smaller economy is going to show up as a bigger percentage change. It has to be. And I pointed out to you, yeah, it's better to go from $100 to $101, $1 addition, a 1% increase, than it is to go from $1 to $2, which is a 100% increase. But when you look at the growth rate, you go, wow, 100% increase. That's really phenomenal. Yeah, but they're only at 2. We've seen a lot of countries that have blown it. Argentina has been one of them. You know, 125 years ago, Argentina was the biggest economy in the Western Hemisphere. An amazing thing to think about, bigger than the US economy. Guess what? 125 years of governments that have blown it, central banks that didn't know what they were doing, corruption, all kinds of issues. In Argentina's economy, while it's one of the bigger economies in the Western Hemisphere, is not one of the powerhouses. It probably, I don't know the exact number, it probably is significantly smaller now than Brazil's economy. When you go to BEA.gov, this is the kind of numbers that you're going to look at. I know it's fuzzy, but on your computer screen it would not be. But these are the kinds of things you look at, and these are the percentage changes that I was alluding to. A couple of other points, and then we'll get to our new work. One of the things that you must understand, must, is that GDP is measured in terms of prices. You know, when we talk about the GDP, we might say it's a GDP of $20.6 trillion annualized. It's expressed in dollar terms, which means what you're taking is the physical, real output of the country and measuring it according to some price index. That price index is called the implicit price deflator. So we say nominal GDP is that price index times real GDP. But you know what? That's just arithmetic or algebra, because you could maneuver this any way you want. You could say nominal GDP divided by the price index gives you the real GDP, which is what we're focusing on when we talk about growth. That's actually what we're looking at. But what you need to know is something about the price index itself, that the price index itself is measuring the prices of all the things that are captured by GDP, meaning all current production that is legal and which has a market value. So if I cook my own food, my services as a chef doesn't get counted. If I buy drugs illegally on the street, while it's a transaction, it doesn't get counted because it's not legal. That said, what we've done over time is that we've created, in the implicit GDP deflator, what we've done is we've created what's called a chain price index, where we do an average of the spares and a PASH index. One of them says, here's a price index that says, how do I compare the prices today? How do I compare the prices, say, in the year 2000 to the prices today? I could say, okay, prices are 20% higher now than they were. Let me start all over again. I'm sorry. The spares price index. It's what you do is you ask, how do I compare the prices in the year 2000 to the prices now? I can say, well, something was $1 in the year 2000. It's now $1.20 in 2021. That would be a spares price index. A PASH price index would say, something costs $1 now. What did it cost in the year 2000? 80 cents. Now you might say, well, actually it's the same thing, isn't it? Well, no, actually it isn't. It isn't the same thing. They're slightly different. If you do the math, you'll find out it's different, because going forward in your view is different from going backward in your view. Think about it this way. Something is $100 and it loses 10% of its value. It's down to 90. But in order to go from 90 back to 100, you got to increase by more than 10%. So going backward and going forward is not the same. What we do is we average the prices using both approaches, and that's how we come up with our price indexes. And finally, what we're interested in is real GDP per capita. What we're really interested in is trying to get the most we can for the largest number of people for the largest period of time. But of course, we know that GDP, while it is the most comprehensive number, it too has its flaws. It counts things that, are really not economic goods per se, meaning positive things. So I remember once my wife and I went on a cruise, and at breakfast, we sat at a table with this guy. We didn't know him at all, and we started to talk to him. It turned out that he was the CEO of a large company, pretty significant guy. The company he was CEO was a Connecticut company called Smith & Wesson. He makes guns. That's what his company does, makes handguns. I don't know how you feel about handguns. Maybe you favor, Second Amendment rights to own them. Maybe you don't. That's really not the point. But the guns and the bullets can turn into violence, which can turn into people needing ambulances and needing medical care and all of that stuff. The medical care, the ambulances, the services of doctors, that all gets counted into GDP, even though that's not really an economic good. You're taking care of GSWs, gunshot wounds. So it's just something to point out to you. So I'll stop here. That's really the big review of the first set of things that we talked about. I'll stop here. 1 or 2 questions on any of this?
I asked a question in the chat. Did you see that?
I can't stop in the middle to look at chats, so why don't you tell me your question?
Okay, so like you say that more population means more economic growth, but I asked that the population of USA is much less than India, but USA has a better economy than India.
Who has the more skilled economy? Who has the better technology? Who has the better management systems and infrastructure? Who has had the better legal and commercial systems? Who has the best natural resources for the purposes of production? And the answer in every one of those cases is the United States. And as I pointed out before, and your question is well taken, simply adding more workers doesn't do anything. As we learned in the growth models, it's not about adding workers. The key is, and it's really maybe fundamental point number one about the solo growth model, it's all about the amount of capital per worker. You've got to get more capital into the hands of workers for your economy to grow. If you don't do that, then your economy doesn't grow. Now, if the capital is old and broken down, well, that's one thing. But if you can keep getting more technology, more capital, and it's better each time you add to it, and as a share of relative to the amount of labor that you have, if that capital is building up, your economy is going to grow. I mean, one of the things that just absolutely made it possible for China to become food independent was that in 1972, they learned from the United States the importance of farm equipment. And the Chinese agricultural sector just has become so much bigger, so much more mechanized than it ever was before. So you have fewer farmers, which is true, but there's so much more equipment now that a country with 1.4 billion, and of course India, which you mentioned, is a little bit smaller than China, but still 4 or 5 times the size of the US. That's what India needs. And as you know, Indian agriculture right now is in the news. The Indian farmers are striking. There's all kinds of problems between the government, the Modi government, and the Indian farmers. And a lot of this has to do with how do you bring things to market? And a lot of that has to do with capital. So I guess that's the answer to that. Thanks for your question, though. It's a really good one. Okay, we're going to go fast. We know that capital and labor are both drivers of growth. We've talked about this. We know that productivity growth in many ways has slowed down in the United States. That's a maturing process. It's not necessarily a sign that something has gone wrong. It may be a sign of an economy that is mature. It's just harder to get productivity growth when you've already set up a productive system that becomes a little bit calcified. It's here already. You know, once a company has put in its robots, it's not going to replace its robots anytime soon. So you get the surge in productivity from the robotics, and then it's going to take years before those robots are used, totally depreciated, you got rid of them, and you go in with a different system. But if you never had robots, your productivity surge is going to be enormous. And so we see that when you compare the economy, say, of South Korea to that of the United States. South Koreans had a smaller, less mechanized economy than the United States, but when it brought in equipment, especially over the last 30 years or so, it was the most modern. And so the automobile industry, you know, in South Korea is really the envy of the world. It used to be that Japan's was the envy of the world. It's now the South Korean is the envy of the world. But it doesn't mean that there's terribly much going wrong here. One of the things that's hurting the US, for example, is that we have shortages of workers in many occupations. Remember, it's the quality and the quantity of workers that makes a difference. So that's one aspect of what's going on. But we were the first economy to become really, really focused on digitalization. Of course, the Chinese have now moved ahead in this, but the digital economy first came here, and digitalization has really taken off really throughout Asia, a little bit less so in Europe. The Southern Hemisphere is way behind. But as you digitalize, you use less packaging, you don't ship as much physically, many outputs are intangible, you can't touch them, it's software, it may be a learning program, it may be something like Zoom. What I'm getting at is when you do all of that, you can't touch it. And the example I gave you, which I would repeat, has to do with the difference between buying a physical computer where you can store your data versus contacting one of the big providers of cloud as a service and saying, all right, I want to put everything I have up in the cloud. You know, I'm looking at my laptop I have a hard drive on my laptop. I have a separate drive where I can store things, which is external. And yet, all of my PowerPoint presentations for my macroeconomics classes, it's up in the cloud. I don't have to store them here. And that's a whole lot safer. They will never be touched. They will be there forever. But there's no physical piece of equipment that's there. It's just absolutely incredible. I'm looking at my laptop. Built into my laptop is, as maybe in many of yours, is a camera. That's how you're able to see me. But I also have a secondary camera that I put here, but I don't need it. I'm not using my separate secondary camera that I plug in externally. I'm using the built-in camera. And more laptops have internally built cameras, which means you don't have to buy separate cameras. It's as simple as that. So all of that weighs on productivity growth because it sort of dampens down output, not to mention your ability to take an unlimited amount of photographs and make an unlimited amount of telephone calls, basically for free. So this is something we watch. We pay attention to total factor productivity, and as I pointed out to your classmate a few minutes ago, we're looking at capital per unit of labor. This is what's really important in terms of figuring out productivity. And from productivity, you get growth, because why be productive? You're productive so you could produce something. Notice the words, produce, productivity. You're trying to create something for sale. When you're more productive, per unit of time, you're creating more output. But in order to do that, you try to maximize in your society the amount of capital per unit of labor. This class today could not be possible, not for an extraordinary amount of capital. I know that some of you are listening on a phone. I know that many of you are on laptops. Some of you are on iPads. Some of you are on desktop computers. Some of you are sitting in a library. I know that for a fact. But look at all the capital that's involved here, and that's the tangible capital. The intangible capital, you all have access to Blackboard Collaborate Ultra. So when we had that question about why is it that India has so many people, but its productivity is so much less per person than the US, this was the answer that I gave to your classmate. Just look at the list here. I'll be quiet. Just look at the list. It speaks for itself. And we've gone over this already twice. Yeah, Dahana, that's absolutely true. Education certainly matters. I sure hope it does, or else what are all of us doing this morning if it didn't matter? But that's a really good point. Of course it matters, and it matters a lot. Thank you for making that point. So these are some of the reasons why countries differ, rich countries, less rich countries. But again, if you go down to, the second point, thus rich countries are rich in large part because, bam, they have more capital per person. Bam. More important, they use labor and capital more efficiently. Bam, there's a difference in the quality and quantity of their workforce education. Exactly the point your classmate just made. Nice job. Well done. So here's the thing. We pointed out that when you look at the marginal product of capital, meaning how much more output per person do you get per unit of capital per person, it's not a straight line. It increases at a decrease. First, it increases at an increasing rate, then at a decreasing rate. That's why it flattens out. That's exactly what you see here. Let's just skip this. It doesn't look good. So we pointed out that we set up production functions, and a production function is nothing more than how you combine capital and labor. And again, we're only looking at capital and labor because we're assuming a two-sector model, no government, no trade, nothing. Everything is produced by some combination of workers working with their capital. So output is a function of capital and labor, and a third of what that output is attributable to capital, 2/3 of it is attributable to labor. Just an assumption, that's all it is. But it really makes a difference. And then you look at that A parameter, that's productivity. You know what? You take the capital and you take the labor, but if you could make them more productive, and remember all the lists of things that are accountable for the level of total factor productivity that we get. 2 or 3 slides back, there's a list of about a dozen things. That's all factoring into that A bar. So if you could make people more productive, and sometimes making them more productive is just a matter of making their workplace more pleasant. You know, maybe that's it. Maybe communicating better with your workers. Who knows? All the different things that can go into it. Motivational tools and things. But what it's saying is that, yes, you take the productivity parameter and realize that when you combine that with capital and labor, that's how you get your output. This is a 2-sector model only, I keep saying, and that's what we pay attention to. So this really refers to the same thing, and we're saying that no, we don't have constant returns to scale. We have negative returns to scale. That means as we get bigger and bigger and bigger, what you could expect to happen by adding an additional unit of capital is positive. You're going to get more output, but the increment more that you get gets smaller and smaller and smaller. This says exactly the same thing, so I will skip it. Let me go down a few because we're really going to the end of this. And please stop me if I'm into anything that you hadn't seen. So here is that concept of marginal product of capital. And by the way, we also have a marginal product of labor. You know, if you were in my apartment right now, I'm sitting on a couch, and I said, hey, could you help me move this couch? So I would take one end, you would take the other end. They say, wow, this couch is heavy. I go, yeah, because there's a folding bed inside of it. It's really heavy. So we get a third person to help us, and we move it better. Then we get a fourth person to help us. So we have the 2 ends, and we have 2 people in the middle, and we're really moving this couch. We're really getting it out into the hallway. Add a 5th person. Now, one of the people carrying says, hey, you just stepped on my toes. You know, come on, be careful. Or you get a 6th person, a 7th person, an 8th person. You don't need those people. What begins to happen is actually the thing begins to wobble because you got too many people, and this one wants to go this way, and this one says, no, stand it up on its end, and you get disagreements. And the point I'm making is that simply adding more people doesn't necessarily solve your problem, that there's an optimal amount of people, there's an optimal amount of capital for the amount of production you're doing, and that's what you strive for. Every business does that. There's a term that the human resources people use. They call it right sizing, getting their size right or correct. The increase in output caused by one additional unit of capital, and it is diminishing. It is a diminishing marginal product of capital. This again just does the same thing. This just takes the math. This again shows that you have a diminishing marginal product of capital. Now, one of the things you see in the remainder of this PowerPoint presentation is a lot of repetition. And I do that deliberately because I'm trying to hammer points into your head. The more times you see it, the more it's likely to stay there, especially if you have an explanation that makes sense to you. So when you see the diminishing marginal product of capital, look, you went from 7 to 8 and you went from like 34 to 35. But when you went from 1 to 2, you went from 17 or 16 to 21. Much bigger gain. That's why we call it diminishing. Okay. When we want equilibrium, we have to recognize that labor gets paid, so there is an optimal wage to pay. And when we buy capital K, we have to realize we're making a decision, which we will come to later in the semester, by the way. We will see this. You're making a decision. What is the value over time of that piece of capital versus not buying that piece of capital at all and maybe putting it into the financial markets? That's what the R would be. The R would be the return that you could get if you didn't buy the capital. Now, oftentimes for R, we use the real interest rate, but that's not actually the case. Real interest rates right now in the US are negative. Negative. We have about a 1.30 10-year yield on Treasury securities and an inflation rate that might be 2.30, which means the real yield is -1. So we really don't consider that. Yet if you put your money in the stock market, especially in 2021, you probably did pretty well. We've talked about the diminishing share of income going to labor. We're almost to the end of this, and then we will get to Mr. Solow. Bear with me for another second. Oh, come on. Okay. So, Robert Solow, Nobel Prize winner in economics, created a model of growth. When you look at it, it looks complicated. When you think about it, it's really very simple. Solow's saying, hey, we combine capital and labor to get outputs. Okay. Capital gets paid for by people spending. I'm sorry, by people saving, because in a two-sector world, income equals consumption plus investment, and income equals consumption plus savings. So in a two-sector world, savings has to equal investment. So the wherewithal to buy capital, which is what investment is the act of buying capital, comes about by having people save. But the fly in the ointment is as follows. The capital that we buy depreciates over time, and it has to be replaced. So given the fact that we have consumption, saving, investment, output, we also now have to consider depreciation of the capital that makes this all possible. So what Solow does is basically say that there is some way of optimizing what takes place in your economy. And that optimal place is called, he calls it the steady state. And this is the place where actually your growth is the fastest, and therefore your consumption, which is really your sense of well-being, is how much you're able to spend, can be maximized. Where you want to go, according to Solow, is to the place where you have invested so much in capital that the only additions to capital that you need to make in order to maximize your output is to replace the things that have been fully depreciated. So when you get to the point where capital that you add, which is of course your investment, equals depreciation, you have hit your steady state. So I explain all of that to you in this page and this page, which is here for you to read. But what I'd like you to do is, I took time over the last, I guess it was Sunday, and I created this chart for you. You have not seen this before. What I did here was, I went through all of those charts that are in the second half of this PowerPoint presentation, and pretty much I combined them into one so that they're all together. And what we'll do now is just sort of go through a lot of this chart, and you'll see where we're going with all of this. So, if you start at the very top of the chart, top right corner, you see y equals the square root of k. That is a way of saying that you have diminishing returns to capital, that the amount of output you get does depend on capital, but it's a diminishing rate of return. So that if you have 100 units of capital, then you would expect your output at any moment in time to be 10. That's effectively what it's saying. If you come down a little bit on the right side, it says depreciation equals 0.02 of capital. He makes the assumption that depreciation is 2%. meaning every year, 2% of your capital stock becomes completely useless and must be replaced. If you come down a little bit further, looking at the production function on the previous page, remember 1/3 to capital, 2/3 to labor? Well, he says, okay, capital, which comes about through investment, is 3/10 of national income, roughly 1/3. The key point here is the steady state. The steady state, according to this particular chart, pulled from Solo, is at a capital level of 225. At 225 capital, at 225 units of capital, investment equals depreciation. Now, why that spot? What is it about that spot that is sacrosanct? Remember that first chart we looked at, y equals the square root of k? If you go up to that point and you draw a tangent to that line, that tangent will have the identical slope as the output curve. What that's saying is that you can't do any better. That's as good as it gets, because if you have less capital, let's say capital was 100, investment would be less than depreciation. You'd have to be increasing your capital. If you increase capital, then you're increasing savings, and if you increase savings, then you are decreasing consumption. So what you want to do here is you need to increase capital. At 300, at k equals 300, investment is less than depreciation, so you decrease your capital. What you're trying to do here is find the spot where the gap between consumption and income or output, y, is the greatest. Then you have gotten to a steady state. That is where your investment equals your depreciation, and there's no incentive to change from there. That's the whole essence of the Solo growth model. So if my articulation of this went past you too fast, if you didn't understand it, I apologize for that. It's hard to listen to, but I put it into writing for you. And I can also tell you that if you go on Google and you just type in Google and you type in explain Solo steady state, you will see explanations from professors literally all over the world. I looked at one from California State University. I looked at one from a European university. They're all over the place. 1,000 different explanations of the same thing, all of us using the same charts, all of us using the same explanations. If you look at the little chart that you see at the bottom of this page, you'll notice how the output function, which is the one on top, it says f of k star. You look at the marginal product of capital, which is that red line, you'll notice the tangent. You'll see how the tangent is exactly as the same slope as the depreciation line. And that tells you that the substitution effect, the substitution rate, is identical. So let me recommend to you that, again, that you study this hard. This is not something that's easy to articulate point by point by point if you haven't studied it before. And again, I invite you, once you have done that, to take a good hard look at this, come back with questions. Okay? Is there anyone with any questions about this now? I know this is hard. I know this is a difficult topic. It's the most difficult topic we'll do all semester. So why don't we back up a little bit and work with it, okay? So we have a savings rate, which is a fraction of the income devoted to investment. So if if output Y is C plus I, but it is also C plus S, that which you consume and that which you don't consume, I equals S. I think that's pretty clear. For a given capital stock K, the production function, meaning output is a function of capital, determines how much output the economy produces, and the savings rate determines the allocation of that output between consumption and investment. Yeah, of course, because think about it, you can only do two things with what you earn. You can spend it or not spend it. You can invest it or not invest it, and if you don't invest it, it's consumption. The savings rate S determines the allocation between consumption and investment for any level of capital. Output, which is a function of capital. Investment, which is a function of savings, how much savings you have. And consumption, which is what's left over from your output minus your savings. Whatever is left over is go to consumption, because Y equals C plus S. That's the C part. That's what you've got. Steady state level of capital, notch it up, is the level where the rate of investment, which depends upon savings, equals the rate of depreciation of the capital stock. We've been there. Steady state capital is the level to which the economy gravitates, much as if it's an equilibrium level. Stop me on any one of these bullet points, because it takes some time to think about them. And you must study this. This is something you have to do. Most of the time, most of the semester, you'll see the things that we do clearly will come out of my mouth. They'll be articulated for you. You'll have them, in an oral sense. Here's something you have to study. Nobody gets this first shot. Okay, so now you increase the savings rate. If you increase the savings rate, then of course you are decreasing the consumption rate. But if you increase the savings rate, you're increasing the investment rate, because S has to equal I. So for an increase in the savings rate S, it implies that the amount of investment is higher for any given level of capital stock. Thus, the increase shifts the saving function higher, which means at any level of income, the amount of savings is higher, so the amount of investment is higher, so the amount of consumption is lower. When that occurs, the initial steady state of capital investment becomes greater than the depreciation, so the capital stock has to rise to a new steady state with more capital and more output. You got to get to the same level of depreciation. I'm sorry, you have to get your capital stock up to or down to the level of depreciation. Steady state consumption is what's left over from steady state output. Well, of course, because output equals C plus I. So if you have your steady state output and you have a certain amount of investment, what's left over is consumption. Or if you have a steady state level of investment, of consumption, what's left over has to be capital. Okay? So you have two conflicting things that are going on. More capital is going to mean more output. We said at a diminishing rate. But it means if you have more capital, you're going to have more depreciation and more capital that must be replaced. I'll stop after this page 1. Is there anything on this page that you're not getting? Any one of the bullet points? There are 1, 2, 3, 4, 5, 6, 7 bullet points here. Anyone stuck on any one of these?
I'm confused in one point, like steady state consumption, this part.
So what's your question?
What is a steady state output?
It's the amount of output you have at the level of capital where the amount of capital equals the amount of depreciation. Okay. Next. So again, let's take a look at similar things, carry it just a tiny bit further. So again, the output is going to go between consumption and investment. Another way to say it is that output goes between consumption and saving. That's why S has to equal I. So in the steady state, investment equals depreciation. So when you get to the steady state, the amount of investment or the change in capital that you have is there only to replace things that have depreciated. Thus, steady state consumption, the portion of the output that is not going for capital, not going for investment, equals the difference between output and depreciation. So think of it this way. Y equals C plus I. C equals Y minus I. C star, or the steady state, equals Y, which is a function of K star, and I, which we now know is the steady state level of capital, K star. So you are depreciating the steady state level of capital. In other words, steady state consumption is maximized where the difference between income and depreciation, which must be offset by more investment. That in turn means more saving and less consumption is the greatest. I told you in the last class, you have to do this by playing with the algebra. If you don't write these equations down on a piece of paper, they're not going to mean anything to you. And then as soon as you do it, I promise you, you're really intelligent students. And beyond that, you're way behind middle school and high school math. You should be able to look at a string of equations and have them make sense to you. And these equations only have 4 variables. There's not much going on here. What makes this so complicated is that you haven't, in many cases, I assume, you haven't really played around with the equations. When you do, you look at it and you go, oh, that's so simple. This is not complicated. It's wordy, but it isn't complicated. Okay, so on the diagram below, that's the little diagram you see on the bottom in the middle. The steady state level of consumption is the difference between what's produced and the output used for investment. Keep saying the same things over and over again. Okay. On the graph, the golden rule, capital stock, is the level of capital that maximizes the distance between the production function and total depreciation. That maximum difference you can see on the chart. You see where you get the vertical dotted line. You see where it says K star on the bottom. Look how the difference is maximized there. That gap is biggest right over there. Whatever did not go into capital had to go into consumption. It's the only 2 things you can do. You can only put things into capital and consumption. So if the output that was produced didn't go into capital, it had to go into consumption. And of course, that's going to be where you're best off. I'll leave it here. This page and the one after, I think the explanations are really good. These are a combination of my words and Mancu's words and Jones's words and something I pulled off the internet. Play with this. We'll come back to this again on Monday if we need to, and we'll see where it goes. I hope, but I really cannot advise you strongly enough to go bullet point by bullet point. Write the equations down on a piece of paper. And all it is substituting. It's just a bunch of substitutions. You're substituting, SF of K for investment, because that's exactly what it is. Investment is the act of building the capital stock, and it depends on savings. So when you do this, you'll play with it, and I promise you, you're going to be very gratified with the work that you do for this. This is not a course that you could take by just not participating in it. Many of you are going to make that mistake, and many of you are going to have a hard time on the exam I'm going to give you in a couple of weeks if you don't play with the equations. okay? I could see that a little bit from the homeworks that was submitted to me, which I'm so grateful for. I'm so grateful that so many of you are doing the homework. But a lot of you have missed the point, and that is that you got to work a tiny bit harder. Now, the next subject that we're going to be talking about is labor markets. It's pretty easy. Then after that, it's inflation, which is pretty easy. There's nothing as complicated as this the entire remainder of the semester. So give this your best shot. Put your effort into it, and I promise you, you're going to have a whole bunch of aha moments where all of a sudden you're going to go, oh man, I get it now. That's so easy. It's not hard. Okay? So that's that. All right, it's 10 minutes to 12. I'm going to tie this up now. As I said, the chart that I drew took all the many blue charts, and when I say blue charts, I'm talking about things like this, that you see in the following, combine them into one place. You'll notice here, for example, it says when K is 100, output is 10. Why? Because output is the square root of capital. Remember that from before. We said that consumption was 2/3 and investment was 1/3, so we made that assumption with 0.3. So if investment is 0.3, then consumption has to be 70%. It has to be 0.7. These are the kinds of things that you want to be thinking about. Okay. You're going to have an exam. It will be worth 20% of your final grade. Exam is going to be on Monday, March 1, the 1st of March. It will be during class time. We will start the class with the exam. You will send me your answers. We will go over the exam immediately thereafter. What that means is no makeups because we will have gone over the test. Be here for the test. Take the test. It's a short test. You'll probably have something like a half an hour to do it. You don't need to do very much. It's all multiple choice questions. You will have to, yes, the exam is multiple choice. There will be all multiple choice questions. You will have to do some calculations. So be prepared to do that. Next, I've told you now on 2 occasions, everything must be submitted to me as a Word document. You will get the exam as a Word document. I will post it on Blackboard. To submit it, you submit it to me as a Word document. Please, I'm begging you, don't send me other formats because I can't handle them. So if you don't know how to use Word, you have a week and a half to learn how to do it. If you don't have Word on your computer or access to Word, learn how to do it. You will send it to me to my email address, which I will provide to you, and it will be due to me by a certain time of day. Probably our class starts at 10:45. You'll probably have to get it to me by, I don't know, something like 11:30 or something like that. All the instructions will be on the exam. All the instructions will also be on Blackboard for you to read ahead of time. It will cover only 3 topics. It's going to cover the stuff we did today, which is measuring the macroeconomy. It will cover productivity and growth models. It will cover labor and labor markets, which we will start working on Monday. We will do that Monday and Wednesday. And on Wednesday, we will go over the homework.
Can you repeat that, Professor?
You will have 3 topics: measuring the macroeconomy, productivity and growth models, and labor markets, which we will start working on Monday and we will finish on Wednesday of next week. And then you will have your exam the following Monday. Everything is submitted as a Word document to an email address that I will give to you. Very, very, very easy. I don't know how many questions. I haven't written the exam yet, but it's a short exam. It's only worth 20% of your grade. So you'll probably have about a half an hour to do the exam. That's that. Now, I notice that you have some sort of study group thing. The study group is a very nice thing to have, but it will constitute cheating on an exam. You're expected to do your own work. If you work together as a group, I will find out about that. And I will fail anybody who cheats. If there is anything in this world that both angers me and disappoints me, it's cheating. There's no need to cheat. If you're not ready to take an exam, you just say, Professor, I'm not ready to take the exam, and we'll see if there's anything we can do about it. But if you cheat on an exam, my wrath will come down on you. So please do not cheat. I expect you to be honorable, because in the working world, in the world in which I live, in the world that I am ingrained in, where corporate ethics and the like matter a lot, I really don't appreciate people who do that. And it isn't going to help you either terribly much, because grading is competitive. So if you're the stronger person in a group and you're giving answers to other people, you're hurting yourself. So I'm asking you, don't cheat. Don't do this as a collaboration. Do your own work. And believe me, I have my sources to find out who collaborated with who. And I really don't appreciate it. Okay? And what I do is something similar to what I've done with my sports teams that I've been a coach. Something that the military does in the United States. If somebody cheats, they don't get penalized. Everybody else does. So if someone in this class cheats, the other 94 of you are going to pay for it. And I have a lot of ways of making people pay for it. So I'm not being difficult here. All I'm asking you to do is be ethical, be moral, do the right thing, and don't cheat. Don't work as groups. Don't have group calls where he goes, what did you get for number 34? Oh, I think it's A. No. None of that. If anyone cheats, the entire class cheats. So please don't do that. And the way I would do that is everybody's grade will get lowered at the end of the semester. I don't want any cheating. I want you to be honest. There will be people who can earn A+. Don't cheat. Okay? Okay, that's it. We will start working on labor markets on Monday. We will do that on Monday and Wednesday. Wednesday, we will also go over the labor market homework. We'll get back into a pattern of doing homeworks on Wednesday. A couple of you have already submitted homework answers, and I truly appreciate that. So thanks a lot. I think we had a really good class today. We covered a lot of ground, and I hope you benefited from it. Okay, take good care, ladies and gentlemen, and have a wonderful weekend.
Thank you, Professor.
You're welcome.